Introducing Chop It Like It's Hot, an automated vegetable slicer from Cutting Edge Inventions Incorporated. As a group, we shared concerns about food prepping in the kitchen. As college students, we are always busy and on the move. Therefore, proper nutritious meals are not always made. We desired a mechanism that would relieve the extra stressor of cutting up vegetables. This device should fully automate the slicing of vegetables and only require the user to insert the vegetable.
Additionally, safety is our top priority. It was found in an article in the Washington Post that knife accidents at home led to almost 330,000 hospital visits in 2011, according to the National Electronic Injury Surveillance System. In a sample of more than 8,000 of these cases, more than two-thirds of these incidents were finger-related injuries. Especially in dormitory settings, various knives and blades are not safe in the residential lifestyle. The goal of the vegetable slicer was to produce nice, even slices at the ease and safety of the user, while still being relatively compact. To meet this demand, we had to design a device that would output a force of 70 newtons and still be within the size constraint of a toaster oven, or roughly 12 inches by 10 inches wide and under 10 inches high.
There are a variety of cutting tools on the market. These range from a $15 hand-guided mandolin slicer to a $25 manual slicer chopper combo. These require more manual labor than desired and require additional safety precautions for the user. And our competition for automated machines range from $40 to over $75 and typically involve a rotary blade that do not provide the same slice as our device.
Analysts expect the global cutlery market to grow close to 6.7% during the next 4 years. Increased popularity of professional cooking at home is one of the major factors that is going to increase the market growth during the forecast period.
Our design options included 3 alternative designs. The first alternative was an offset crank slider. For this design, the blade would be making vertical cuts so that the slider would be tracking up and down to chop and the vegetable would be directed horizontally towards the blade. This alternative was initially ruled out because it did not have the assistance of gravity. Instead, the user would have to push the vegetable from an awkward angle. Additionally, through kinematic analysis and experimentation, we found that the extra force applied from the offset did not benefit the cutting process and was deemed unnecessary.
The second alternative design involved 2 meshed gears. One of the gears would transfer the power of the motor, while the other gear would contain the blade. We decided to not pursue this design because to fit within the size constraints, the driving gear would have to be 1/10 of the size of the follower gear that included the blade. Therefore, the driving gear would be significantly smaller. This means the driving gear would need to be manufactured with extreme precision to ensure meshing between the gears, thus increasing material and production costs.
The third alternative design was an inline crank slider. This entire mechanism moves in the horizontal plane. Therefore, the vegetable is then inserted vertically. This design allowed for the device to fit within our design constraint while also having the desired stroke length of 3 inches and the ability to make straight cuts. Through kinematic analysis, the smooth, constant motion of the slider was desired to ensure fine, even cuts. We ultimately thought this design met the consumer's need best and chose the inline crank slider as our final design. Overall, we spent less than $30 on the materials for our prototype. These materials included wood for the structure, plastic bin for the base, Tupperware for vegetable collection, various fasteners, and the purchase of an existing mandolin slicer for the interchangeable blades. This decision matrix helped weigh all of the criteria for the alternatives and made sure we had a calculated decision. As seen, the inline crank slider had the highest score and was the right choice for our design. For mass production, we would use injection molding to make the length, slider, blades, and vegetable guide as one cohesive unit. It would have 8 separate components that could easily be assembled and disassembled for cleaning and storage.
Moving forward, there are some challenges and concerns we will need to address. The current prototype is still bulky. However, through professional manufacturing methods, the plastic molded parts could be made to snap in and out of position between uses instead of being permanently attached. That way, it would be user-friendly and you could take out the part where you insert the vegetable for easier storage. Also, the motor would be hidden in a compartment and a single on-off button would be placed to turn on the device. An additional improvement that could be made is to put some type of handle on the various blades to make replacement easy and clean.